Hi everybody, so today we are doing our last note in coordinate geometry, and this is our most challenging. We are going to learn how to determine the area of a triangle by just knowing the coordinates of its vertices. So this is challenging because although we know how to find the length of a base of the triangle, the challenge is finding the length of the height of a triangle. So again, area is base times height divided by 2. So if we look at this triangle, you can choose any of the sides to be the base. But if you choose AB to be the base, we can actually find how long that base is. We know our distance formula. That shouldn't be a big challenge at this point. But how do we find the height? So the height, remember, comes from the opposite vertex and will hit this line AB at 90 degrees. So essentially, we need to find out where this line segment will hit AB at 90 degrees. That will also go through C. So again, we need a line that is perpendicular to AB, but goes through the opposite vertex. And if we find where that hits, at what point that hits AB, we can then find the distance between that point and C. So GeoGebra allows us to find it rather nicely. So I'll show you how to do that first. So basically, I've just created the triangle. I'm assuming at this point you know how to do that. And you want to go to construct perpendicular line. Now notice when you pick this in the bottom here, it'll say pick a line and a point. So I want it to go from this line to this point. And that constructs your perpendicular line. So you need to find the spot here where it actually hits. So you scroll up to point, and you want to make sure you're dropping it right on that point of intersection. And GeoGebra is smart. It usually knows what you're doing. Okay, so if you can click move and right click on this to see what this point actually is, and we will be finding this shortly. This is actually negative 15 over 13 and 10 over 13, but those are the decimal approximations. So then down here, you can go to measure distance or length. So then you click from D to C, and it gives you the distance from D to C, and then A to B, and it gives you the distance from A to B. So now you simply need to do AB times DC, so that's base times height divided by 2, and that's it, you're done. Okay, now it's important though, if you do use GeoGebra in order to do this, that you actually put the entire decimal representation in and not just 3.88, and you will see why when we get to the algebra. Okay, so let's go ahead and actually do this exact same triangle by hand. Okay, so remember the area of a triangle is just base times height divided by 2. So therefore, we need the length of the base and the length of the height in order to find the area of a triangle. So first of all, you need to choose a line segment as our base. Let's choose AB here. You can choose any line segment, and then that'll just change where the height is. The area would be the same, but let's just choose AB. So we use our distance formula. The difference in the x's, so 3 plus 3 in this case, squared plus negative 2 minus 2 squared. Okay, and if you do the math, you get root 52. Now, I want you to keep this distance as an exact value. Notice on GeoGebra, it had it as a decimal, but as we do our calculations, that's a 5, by the way. Keep it as a exact value, as a square root, and you'll see why shortly. Okay, so now we need to find the length of the height. This calculation requires many steps. The height of a triangle must intersect the base, so AB in this case, at 90 degrees, and it has to go through the opposite vertex. So to find its length, first we need the coordinate where it intersects the base. So in order to do that, we need to find the point of intersection between AB and this line, which is called the altitude, the height of the triangle. So we need an equation for each one. So first we'll find the equation of AB. So the slope of AB is equal to, I'm going to assume at this point that you guys know how to find slope. It's equal to -2/3 once you find it. And then we can put in either of these points, 3, -2 or -3, 2 to find the y-intercept. And you get that the y-intercept is 0. So you get y equals -2/3 x is the equation of AB. Now we need to find the equation of the height. Okay, so the height is parallel to AB. Sorry, not parallel, perpendicular. So it's so its slope is perpendicular to AB, so it is positive 3/2. Okay, now it goes through C, which is 1, 4. Okay, so 4 equals M 3/2 x 1 plus b. So when you solve this, you get that b is equal to 5/2. And so the equation of the height is y equals 3/2x plus 5/2. Okay, so that means it goes through at 2.5. And it does intersect. We'll find where it intersects in a moment. Oh yeah, so now we need to find the point of intersection of these two. So we have a little bit of space for that down here. So we just set them equal to each other. So -2/3 x equals 3/2x plus 5/2. Okay, so you add this and you end up getting, actually no, I multiplied this entire beast by 6. The lowest common multiple of the denominators just to get rid of the denominators. So that gives me -4x equals 9x plus 15. And so when you solve this, you get -13x equals 15, or x is equal to -15/13. Okay, when you sub that back in for y, you get 10/13. So your coordinate is -15/13, comma 10/13. So not a very pretty number, but that's what it is. Can't always be pretty, so it's about there. So here is our height. So you can name that point D or something like that. So we found it to be -15/13, 10/13. Okay, so now we have the point of intersection, we can find the length of the height. So that distance, or the height actually is what it is the distance between this point, even though it's a nasty fraction, and the point C. So you put in 1 plus 15/13 all squared plus 4 minus 10/13 all squared. Now what I want you to do is get good at using your calculator so that you get an exact value, so 196/13, and leave it as an exact value. Okay, so if you use the fraction button on your calculator, you should be able to achieve this. Okay, now if you do a decimal, you must have absolutely no rounding. So if you choose 3.882901374 because you just find this too challenging, that's okay, but do not round. Write down every single last decimal that your calculator will give you. Okay, so step 4, now we use our base times our height and we divide by 2. That's the area formula. So area equals base, so √52 times height, so √196/13 divided by 2. Now, if you put this in your calculator, you will get exactly 14 units squared. No decimals, nothing. So that is why you want to keep everything as an exact value so that you get that nice, pretty answer at the end. Okay, so I know that's quite a bit to take in. It's quite a lengthy algebraic process. So let's do one more example. And I would invite you to try this on GeoGebra.